Welcome back to Module 2. In this session, we'll focus on the structural side of SIPs. We'll look at how these panels carry loads, what testing standards they must meet, and how engineers evaluate them compared to conventional framing. By the end, you'll understand why SIPs are not just insulation panels, but truly structural building components. When people first hear about SIPs, they often assume they're just big pieces of insulation. But that's not the case. Structurally, SIPs behave like an I-beam. Think of the OSB faces as the flanges of an I-beam, taking on compressive and tensile stresses. The foam core acts as the web, transferring shear loads and preventing the faces from buckling. When these three layers are bonded, the panel becomes a rigid structural element capable of carrying vertical and horizontal loads. This composite action is what allows SIPs to serve as exterior walls, roof systems, and even floor systems without additional framing. In other words, SIPs are both the insulation and the structure. Let's talk numbers. A standard SIP wall can carry axial loads well beyond typical residential requirements. In fact, many SIP walls can support more than 2 stories of load-bearing construction when properly designed. Roof panels, depending on thickness and span, can resist snow loads exceeding 100 pounds per square foot. This means SIPs are not only suitable for single-family homes, but also for multi-family and light commercial projects where structural demands are higher. The important thing to remember is that just like any engineered system, SIP load capacity depends on proper design, panel thickness, span length, and support conditions. That's why manufacturers provide span tables and design guides that engineers use to size SIPs appropriately. Now, how do we know SIPs can do all this? The answer is rigorous testing. SIPs are evaluated under ASTM standards, for example, ASTM E72 for racking shear, and ASTM E1803 specifically for structural insulated panels. Tests measure bending, compression, racking shear, and connection strength. Results are then used to create design values that engineers can rely on. In fact, SIPs are recognized in the International Building Code, IBC, and International Residential Code, IRC. That means engineers and building officials have a clear pathway for approving SIP projects, just like with traditional framing. So when someone asks, will the building inspector allow SIPs? The answer is yes, provided you follow code-approved design methods. Beyond strength, SIPs also undergo fire and seismic evaluations. With fire, SIP walls and roofs are rated based on the protective finishes applied, typically gypsum board on the interior. Properly finished SIP assemblies can meet 1-hour or even 2-hour fire ratings required by code. For seismic, SIP perform extremely well because of their stiffness and lightweight. The panels distribute loads across large surfaces, reducing the stress on individual connections. That makes them a good choice for seismic zones, provided detailing is done correctly. The takeaway here is that SIPs are not just strong in theory, they're proven in both lab tests and real-world performance. A panel is only as strong as its connections. In SIP construction, panels are joined with splines, adhesives, and fasteners. These connections transfer loads between panels and ensure the building behaves as a continuous structure. There are several types of splines: OSB splines, insulated splines, and structural lumber splines. Each has its place. For example, OSB splines minimize thermal bridging, while lumber splines provide extra strength where needed. Engineers pay close attention to these details because the connections are often the limiting factor in SIP performance. With correct detailing, connections maintain the integrity of the SIP system under both vertical and lateral loads. To sum up, SIPs are structural panels that act like giant I-beams, carrying vertical and horizontal loads with efficiency. They're tested, code-recognized, and proven in both fire and seismic conditions. And with the right connections and design, SIPs can perform as well as, or better than, conventional framing systems. In the next module, we'll shift gears and talk about sizes, dimensions, and shop drawings, essentially, how SIPs are customized for each project. That's where we start to see the flexibility of this system in action.